Hello everyone, let's solve some few more numerical problems on relation between wave numbers. So, to start with, the first problem states that we need to show when all the losses are of the magnetic type, then eta equals to k by mod of y, that is equals to k bar minus k bar upon omega epsilon minus j k double prime upon omega epsilon. So, we need to show eta equals to k prime upon omega epsilon minus j k double prime upon omega epsilon. So, let us start solving this. So, we are given that since this is of the magnetic type, so we are given that sigma equals to epsilon double prime is equal to 0. Okay. So, we know that eta is root over of z cap by y cap, where y cap is sigma plus j omega epsilon. So, sigma is 0. So, we have it as j omega epsilon. Also, z cap is j omega mu. Now, we know that wave number and the intrinsic impedance are related by z cap as j k eta and y cap as j k by eta. Therefore, eta can be written as z cap by j k, that is j k by y cap. Therefore, substituting for z and y, we get eta as j k divided by y is j omega epsilon. So, j omega epsilon, that is equal to, so j cancel out, we get k by omega epsilon. So, k is written as k prime minus j k double prime upon omega epsilon, that is k prime by omega epsilon minus j k double prime by omega epsilon, where k prime is intrinsic phase constant, and k double prime is intrinsic attenuation constant. Okay. So, we will move to the next problem. The next problem is that we need to show that for non-magnetic dielectrics, k prime is given by omega root under mu epsilon prime into 1 plus 1 by 8 q square, where k double prime is given as omega epsilon double prime upon 2 multiplied by root under of mu by epsilon prime multiplied by 1 minus 8 q square. R is given as root under of mu by epsilon prime 1 minus r by 8 q square, and x is given as epsilon double prime by 2 epsilon prime multiplied by root under of mu by epsilon prime 1 minus 5 by 8 q square, where q is the quality factor and is given by q equals to omega epsilon prime divided by sigma plus omega epsilon double prime. Okay. So, again we will start solving. So, it's given that quality factor is written as omega epsilon prime divided by sigma plus omega epsilon double prime. So, again we will start with z cap and y cap. So, z cap is given by j omega mu and y cap is given by sigma plus j omega epsilon, that is equals to sigma plus j omega epsilon prime minus j epsilon double prime. Fine. So, first we will start with finding out k. So, k can be written as root under of minus z cap multiplied by y cap. So, we will substitute this z and y and we will get minus of j omega mu sigma plus j omega, in place of epsilon we are writing epsilon prime minus j epsilon double prime. Okay. Now, we will simplify this, just open up the braces. We will get minus of j omega mu sigma plus j omega epsilon prime plus omega epsilon double prime. Further simplification gives minus j omega mu sigma, we are multiplying this, opening up the braces. So, we get minus j omega mu sigma plus omega square mu epsilon prime minus j omega square mu epsilon double prime. That is equals to, now what we will do, we will take out the common terms. So, we minus j omega mu, we are taking it as common, then we will have this sigma from the first term itself, sigma, then plus from the third term we will get omega epsilon double prime. Okay. And the second term we write it as plus omega square mu epsilon prime. Okay. Now, we can write, simplifying, that omega square mu epsilon prime, okay, 1 plus, sorry, this will be minus, okay. So, omega square mu epsilon prime we have taken and then it is 1, then minus j omega mu sigma plus omega epsilon double prime divided by omega square mu epsilon prime. Okay. Then we can write this as omega square mu epsilon prime 1. So, this 1 omega will cancel, okay. This mu will also cancel, we can write it as 1 minus j sigma plus omega epsilon double prime divided by omega epsilon prime. Okay. Now, this omega square mu epsilon prime. I am just taking it and just outside the square root. So, we will have omega mu epsilon prime, okay, and then we are having here as 1 minus j, and this term, this we can write it as in terms of q, okay. So, it will be 1 minus j multiplied by 1 by q, okay, and this is raised to the power half. Because it is given in the question that q is omega epsilon prime by sigma plus omega epsilon double prime. So, we just substituted q in place of it. Okay. Now, we need to expand this, okay. So, we can note it like this, that 1 minus x raised to the power r can be expanded as 1 minus rx plus 1 by 2 factorial r multiplied r minus 1 x square minus 1 by 3 factorial r minus 1 r minus 2 x to the power 3. Fine. Now, using this and then expanding, we will get k as k equals to, we can write it as omega mu epsilon prime, and now we will expand this. So, we will get 1 minus r is half. So, 1 minus half into x is here 1 by q, j by q. So, it will be 1 minus r is half, in place of x we will write j by q. Fine. Then plus 1 by 2 factorial r is half, r minus 1 is r minus 1, that is half minus 1. So, it will be minus half, okay, and x square. So, x is j by q. So, x square will be j square by q square, okay, and then minus 1 by 3 factorial r will be, again r is half. So, half r minus 1 will be minus half, r minus 2 will be half minus 2, that is minus 3 by 2 x is cube. So, x is j by q. So, in place of x is cube we will write j cube upon q cube plus this, okay. Now, on further simplification, we can write this as omega mu epsilon prime. So, the first term is 1, then we are having minus j by 2q plus this is 2 factorial. So, 2 factorial is 2. So, 2, 2, 2. So, 2 to 4, 4 to the 8. So, 1 by 8, and this is j square, and this minus we will get plus. So, q square. Then again this one. So, 3 factorial is 6, 6 multiplied by 2 is 12, then 24, and then again 1 2, that is 48. So, basically 3 upon 48, that gives us 1 upon 16. So, it will be 1 by 16, right, and here it is j cube, that is 1 minus. So, basically we will having a we will having a plus over here. So, 1 upon 16, this will be j upon q cube. Okay. Now what we will do, since we need to find k prime and k double prime, from this equation we will be separating the real part and the imaginary part. So let's write it as separating real and imaginary parts, separating the real and imaginary parts, we will have k equals to omega mu epsilon prime. So the real part we are having only this 1 plus 1 by 8q square. Okay. And for the imaginary ones we will have again this omega mu epsilon prime. The imaginary parts we are having this minus j by 2q plus 1 by 16 times j by q. Okay. So we will write it as omega mu epsilon prime 1 plus 1 by 8q square. So minus j will take it outside, so minus j omega mu epsilon prime. So minus j comes out, so here we will have within the brackets like we will be having 1 by 2q minus of 1 by 16 q cube. Okay, fine. Now give this equation number as 1. Now comparing this equation 1, so we can write it like this, like comparing the above equation with, so we know k is written like this, k equals to k prime minus j k double prime. So what we will do, comparing 1 and 2, okay, we will get, so k prime we will get, therefore k prime we will get it the real part, that is omega root under mu epsilon prime 1 plus 1 by 8q square. Okay. So k prime is this, so this we got, so this is proved. And for k double prime we will take the imaginary part, so k double prime we will get like omega root under mu epsilon prime, this is like 1 by 2q minus 1 by 16 q cube. Okay. So from this we can take 2q common outside the braces, so it will be omega mu epsilon prime root under upon 2q. This 2q we are taking outside common, so we will have inside the braces we will be having 1 minus 1 upon 8q square. Okay. Now what we will do, we will substitute for the value for q. So we can write like this: omega mu epsilon prime. Okay, so this is 2. So for substituting the value of q, we will write, in place of q we can write omega epsilon prime divided by, so this divide comes in the numerator as sigma plus omega epsilon double prime. Okay, and then we have inside the braces 1 minus 1 upon 8q square. So this we can write as, here this omega and omega will cancel out. Okay, and this we can write it as mu upon epsilon prime. Okay, so sigma is 0 and then omega epsilon double prime upon 2 and then 1 minus 1 by 8q square. So this is our k double prime. So this is also proved. Fine. Now for the resistance and the reactance. Okay. So for that we will start with the eta. So first and second done. For third and fourth we will start with, we know eta is given by root under of z cap upon y cap. So again what we will do, we will substitute for z cap and y cap and then proceed in a similar manner as the previous one. Okay, so let's start this. So you can write eta as, z cap will be j omega mu upon y is sigma plus j omega epsilon. Okay, so this is our eta. This we can write as j omega mu upon sigma plus j omega epsilon prime minus j epsilon double prime. Okay, in place of epsilon we are writing epsilon prime minus j epsilon double prime. So this. Now what we will do, we can again write this one as j omega mu by, so sigma 0, this will be j omega epsilon prime plus, so this j square is minus 1, minus and minus, this becomes plus, minus minus, this becomes plus. Okay, so it will be j omega epsilon prime plus omega epsilon double prime. Yes, that is, we can write it as, we take out mu upon epsilon prime as common and we can write down it as j omega upon j omega plus omega epsilon double prime by epsilon prime raised to the power half. Okay. On further simplification, we write this one as mu by epsilon prime j omega, this epsilon prime from the denominator we are taking it up on the numerator. So it will be j omega epsilon prime upon j j omega epsilon prime plus omega epsilon double prime raised to the power half. That becomes mu upon epsilon prime. So this we can write it as dividing by j omega epsilon prime, we get 1, this is also 1, plus omega epsilon double prime upon j omega epsilon prime raised to the power half. We are just doing in this approach because we will be substituting this value as q. Okay. So next we can write this one as mu upon epsilon prime 1 upon, we can write this one as 1 by j q, correct. So this is mu upon root under mu upon epsilon prime 1 by 1 plus 1 by j q to the power half. Okay. Therefore we get eta as mu upon epsilon prime square root of this, and this we can write as 1 plus 1 by jq raised to the power of minus half. We just made it as raised to the power minus half. Okay. So now this will again be expanding. So we know, just as a note we can write, so for expanding it is in the form of 1 plus x to the power r, that is can be expanded as 1 plus rx plus 1 by 2 factorial r multiplied by r minus 1 x square plus 1 upon 3 factorial r minus 1 r minus 2 x is cube plus dot dot. So using this expansion we will write the above equation and we will expand it as mu upon epsilon prime, mu upon epsilon prime, this one is, so the first one will be 1 plus rx, in this case r is minus half, right. So r will be minus half, x is 1 by jq. Okay. So we have 1 plus rx, next we have plus 1 upon 2 factorial. Okay. So 1 upon 2 factorial and then r is again here minus half. So r is minus half, r minus 1 will be minus half minus 1, that is minus 3 by 2, and x square will be 1 upon jq square plus it will be 1 upon 3 factorial, then r, that is minus half, r is minus half, and r minus 1 will be again minus 3 by 2, r minus 2 will be minus 5 by 2, this is 1 by jq cube plus. Okay. Now simplifying we will get eta as mu upon epsilon prime, we will have this as 1 minus of 1 upon 2 jq q. Fine, and this is 2 factorial, 2 to 4, 4 to the 8, so 3 by 8. Okay, 3 by 8, and again we are having a this will minus minus, and then we will have this as minus, so minus 3 by 8 q square. Okay, the third one we will have, sorry, the fourth one will be again 3 factorial is 6, so 6 to 12, 15 by, so it's 15 by 48, okay, 1 by j k q. Fine. Now again what we will do, we will separate the real and imaginary parts. Okay, so let separating the real and imaginary parts, separating the real and imaginary parts as, we will get eta as mu by epsilon prime. Okay, so the real part is 1 minus 3 upon 8 q square plus mu by epsilon prime. This one will be upon epsilon, this one will be minus, of course, minus 1 upon 2 jq plus 15 by 48 1 upon jqqq. So now we have separated the real part and we have separated the real part as well as the imaginary part. Okay, now we can write this mu upon epsilon prime 1 minus 3 upon 8 q square plus mu upon epsilon prime. This will be, so it's 1 minus 1 upon 2 jq, so we'll write it this like j by 2q minus of 5 by 16 j upon qq. Therefore the real part gives this as mu upon epsilon prime 1 minus 3 by 8 q square. Okay, so this one is proved, and from the imaginary part we will get, x as mu by epsilon prime. This will be 1 by 2q minus 5 by 16 q cube. Okay, so now just simplifying a little bit more will yield root under of mu by epsilon prime. So here 1 by 2q comes out of the bracket, and 1 minus, we are left out it, 1 by 2q got out, so we will left with 5 by 8q square. Fine, that gives us mu upon epsilon prime. So again we will substitute the value. For q we will be substituting over here, so we will get 1 upon 2 multiplied by omega epsilon prime upon omega epsilon double prime 1 minus 5 upon 8 q square. So we get it as mu upon epsilon prime. So this is this omega cancel out and we are left with epsilon double prime 2 epsilon prime 1 minus 5 upon 8 q square. Okay, so this is also proved. So on next class we will also solve some few more problems on wave numbers and then we will move into electric current source. Thank you.